So here is another question on temperature measurement and thermometers. So it is given that a constant volume gas thermometer using helium records a pressure of 20 kilopascal at the triple point of water, at the temperature of triple point of water, and it also records a pressure of 14.3 kilopascal at the temperature of dry ice, solid CO2. We have to calculate the temperature of dry ice. So here the relationship that we studied in constant volume gas thermometer, we have discussed it in the theoretical part. So please watch all the theoretical concepts in the thermodynamics playlist, okay, related to heat, temperature, temperature scales, different types of thermometers, temperature measurement, everything we have discussed. So here the relationship that we'll be using is this: PTR by TTR is equal to P by T. Here P, TR, it is the pressure at triple point of water, okay. TTR is the temperature at triple point of water. This is equal to how much? 273.16 Kelvin. Here the data is not given, so you have to remember. I mean, it's expected that you remember it, okay, 0.01 degrees Celsius. Then it's also given P by T, where P by T is the pressure and temperature readings at any other condition. So here the other condition is for dry ice. This whole thing, it now is considered for dry ice conditions here. So here the pressure reading is given, pressure at dry ice, that is equal to 14.3 kilopascal, and the temperature of dry ice that we have to measure. So here we will use this concept that implies T is equal to, here T will go on this side, and this P into TTR by PTR, this, okay. So this will be the formula which we'll be using to calculate the temperature of dry ice. So here this temperature of dry ice is equal to pressure of dry ice into triple point temperature by triple point pressure. So here this is the dry ice pressure, and this is the temperature of dry ice which we have to calculate. So that is equal to 14.3, both are in the same units, kilopascal, so they will cancel each other out, into 273.16 Kelvin by 20 kilopascal, which is the triple point pressure which is given. So if we calculate, it's coming around 195.30, this much Kelvin. This is the temperature of dry ice, okay. This is the temperature of dry ice, okay. So this is the concept, and this is the formula which you should be aware about. This one, PTR by TTR, which is equal to P by T. PTR and TTR are triple point pressure and temperature. P and T is pressure and temperature in any other conditions, okay, that. So here is another question on temperature scale and temperature measurement. it is given that in an arbitrary scale of temperature, water freezes at 40 degree and boils at 290 degree. Find the boiling point of a liquid in this arbitrary scale if it boils at 62 degrees Celsius. Okay, so here again we'll be using the concept of interconversion between one scale and another. So here we have first the arbitrary scale, and then we have is the Celsius scale. Please pay attention here that here nothing has been mentioned, only degrees, 40 degree to 90 degree, and here it is given that the same liquid it boils at 62 degrees Celsius in Celsius scale. So the basic concept is that we have to take the reading in one scale minus the lower fixed point for that scale, which is equal to, for Celsius it will be 0 degrees Celsius, by upper fixed point, which is 100 degrees Celsius, which is the boiling point of water, and minus the lower fixed point. Okay, so for the arbitrary scale, here the same thing, we have to take the temperature in the arbitrary scale minus the lower fixed point. Here water freezes in this arbitrary scale at 40 degree. So the same is the lower fixed point. 40 degree is the lower fixed point for the arbitrary scale, and the boiling point, which is 290 degree, it is the upper fixed point for the arbitrary scale by 290 degree minus 40 degree. This is the same as this. Now we have to find the boiling point of a liquid which boils at 62 degrees Celsius. In Celsius scale, the boiling point is 62 degrees. So here Tc is equal to 62 degree, and we have to find its equivalent temperature in the arbitrary scale. This we have to find. So we'll simply substitute the values. So same, Ta is unknown, the temperature in arbitrary scale is unknown. So Ta minus 40 by 290 minus 40 is equal to, the temperature in Celsius scale is 62 degree for the liquid. Okay, so here I'm writing for the unknown liquid or the liquid. So the boiling point in Celsius scale is 62 degree. 62 minus 0 by 100 minus 0. Okay, that implies temperature in arbitrary scale minus 40 by 290 minus 40, that is equal to 250, is equal to 62 by 100. That implies Ta minus 40 is equal to 62 by 100 into 250. Okay, that implies temperature in arbitrary scale is equal to 62 by 100 into 250 plus 40. Okay, so it is coming around, the result, it is equal to 195 degree. So this 195 degree is the boiling point of the liquid in this arbitrary scale. The same liquid has boiling point of 62 degrees Celsius. Okay, 62 degrees Celsius in Celsius scale. In Celsius scale, the temperature is 62 degrees Celsius, but in this, according to this arbitrary scale, it is 195 degree. No units, because it's arbitrary, nothing has been mentioned which scale it is. So simply 195 degree. So the same liquid which boiling point is 62 degrees Celsius, it is 195 degree in this arbitrary scale, and this is in Celsius scale. Okay, so this is the thing. Same concept of interconversion from one temperature to another temperature, and this formula is very important.